Good morning, everybody. Welcome back to lecture number 17. Today we will start with the last part of the previous checkpoint. So in the previous checkpoint, we stopped at the last problem where it was asking us to calculate the phase shift. So what we had is he was telling us that VM is 110 RMS. He was telling us the frequency is 60, and he was telling us an information that peak voltage is at T equal 5 millisecond. Okay? And he wants to write the expression. So the expression, I told you, you have to put the peak. What's the peak? 110 times the root of 2, which is going to be 155.6. And then you put sine or cosine? Cosine. What is omega? 2 pi f, which is 377. What's the unit of omega? Radians per second. So 377 times t. You always keep the t, indicating that it's a function of time. Get it? And then we have to add the phase shift theta. We don't know what is theta. To calculate theta, quiz 4, okay? Quiz 4 may ask you how to calculate theta. To calculate theta, he's telling you the peak voltage is at 5 milliseconds. It means what? It means cosine of 377 times 5 milli plus the phase shift equals to 1. When the angle cosine of what gives me 1?
0.
Cosine of 0. So I have to say 377 times 5 10 to minus 3 plus theta equal to 0. So theta equals minus 377 times 5 milli. And if you do the math, you should have the angle in radians, which is minus 1.885 radians. Convert this to degrees. Well, I remember this from high school. Do you remember this from high school? سين على 180 تساوي د على باي. Do you remember this from high school? What was the letters, Adnan, in high school? No. Sin? It was sin like that? ودال على الراديان? Yeah. Okay, so I think it was degrees and radians. So I have radians and I want degrees. It will be 180 over pi times radians. So it will be minus 108 degrees. Minus 108 degrees. Get it? So you make whatever here equals to 0 and you solve for theta. Done with the checkpoint. Remember this formula, okay? Degrees over 180 equals radian over pi. Today we'll talk about phasors. Now, I want to ask you a question, okay? Let's go back to the original equation. V of t equals Vm cosine omega of t plus theta. Or we can rewrite it as Vm cosine of 2 pi f t plus theta. My question is, are the variables here that can define the cosine signal that varies from signal to another only. يعني ايش هي الاشياء اللي في الدالة هذه اللي تعرف لي اياها المهم مرة عشان في الكهرباء. What's the first one?
The amplitude Vm.
The amplitude Vm is cosine a function. Math function. Leave it. 2 pi. Leave it. Frequency we always know. We cannot change it. For the same sinusoidal signal, for the same frequency, we keep it the same. Okay? In every circuit, the frequency is fixed. Sometimes 60, 10. Time always fly. Time will always fly. But the phase shift is the other quantity that would vary among signals in one circuit. That's the key word. They vary in one circuit. So in one circuit, you will have a voltage source. If you measure the voltage here, you will have frequency 60, always maybe, or frequency 20, whatever. But this is fixed for the whole system. The only thing that varies, if I have a VDR here, then we have a maximum or amplitude will change. And also I have the phase shift will change. So those two numbers constitute what we call a phasor. So a phasor of this signal is Vm at angle theta m. No, not m. At angle theta. In other words, if I know V and theta in a circuit, I can reconstruct the time domain function. So this is time domain, this is phasor domain. Why we do this? Because we don't want to write cosine 2 pi f every time in our circuits. We are lazy, remember. We are lazy. We do not want to write whatever functions in the circuits every time. We just write the phasors. Get it? That's in summary what we will discuss today, phasors. But before that, let's review complex numbers. In a complex number, I told you last time, we have a format of a plus j times b. And we say j is the square root of minus 1 instead of I because I is reserved for the current. We have the number a, which is the real part. The number b is the imaginary part. You remember that from math, right? The complex number can be represented as a vector in the complex plane or a phasor. In other words, if I go on the real axis by A and the imaginary axis by B, I can draw a vector. The length of this vector, which is square root of A squared plus B squared, is called the magnitude, okay? It is also at an angle theta that's calculated by tan inverse A over B. Or B over A. المقابل على المجاور. المقابل اللي هو B. If you draw a triangle here, that's B. المقابل على المجاور. High school. أبو نصار. What is, how to find theta? Tan inverse of B over A. Do you remember that from math? 01 or 02? Okay. The length of the vector is the magnitude. The angle is measured counterclockwise. Now there is a formula that we have to memorize, which is called Euler's identity, which states e to the power j of theta is nothing but cosine of theta plus j sine of theta. Or I can rewrite it, e to the power of j times whatever, the whole thing, whatever, equals cosine of whatever plus j times sine of whatever, okay? So whatever here can be anything. Can be omega t plus theta. Can be a resistor. Can be whatever, anything. I can rewrite it in Euler's identity. Why I said whatever is maybe we can have it e to the power j times omega t plus theta, which will be cosine of omega t plus theta plus j times sine of omega t plus theta. In other words, I can have a cosine plus sine of real-time expression. So this is what we call a rotating phasor. Every time this phasor changes, if you create it as a function of time, it will rotate, okay? Yes?
هذا خاص بالفيزر؟
Well, this is complex numbers, no phasors here. This is math, 01, 02, 208, 201, I don't know. Okay?
ليش استعملناها بدل ما نستعمل شيء قانون؟
Well, I'll explain it later. This is just complex number, okay? Okay? It's telling you a phasor is only the real part. So, for sinusoidal voltage, which we have in this course, V1 of t equals V1 cosine omega theta of t plus 1. So we define the phasor as bold V1 equals V1 of angle theta 1. So the phasor can write it as bold, but because I'm writing on the board, I'm not gonna call board, I'm just gonna call it whatever. I'm gonna put an arrow instead of bold يعني phasor. Do you like me to create a new notation? In the slides it's bold, it's phasor, but maybe I can call it like that. V with hat. The phasor V. Let me remember, how did I represent phasor to the previous class that I took? Well, I'm gonna do it that way. V sub phasor. Okay, you like that? هذه تمثل information about the voltage drop written in the phasor format. Theta is the phase shift. We'll explain it over time, but what you want to know is what you need is the max and theta in every segment. So we call it V sub phasor equal Vm times theta. In the slides it is bold, okay? In the sinusoid of that form, we have V2 equal V2 cosine. I already explained how to convert from sine to cosine. So this can be rewritten as cosine of omega t plus theta 2 minus 90. If you convert, then the V2, which is the sine, is actually V2 times theta 2 minus 90 degree. To write it as a phasor, you have to put it in terms of cosine first, and then write it as a phasor. So last lecture we explained how to convert from sine to cosine, right?
Yes.
Minus 90. To write it as a phasor, take whatever sine angle you subtract it with 90, because phasors work with cosines, okay? Do you see why we subtracted 90 here? Exercise. If I have a current I1 of t equals I1 cosine omega t plus theta 1, I can write I phasor, which is I1 phasor, So if I have I of t, I1 of t equals I1 cosine omega t plus theta 1, to write I1 phasor is I1 angle theta 1. I have I2 to be sine, so I have to convert it first to a cosine, then it will be I2 theta 2 minus 90 degree. Okay? Let's continue. Why we do phasors? If I tell you if I tell you, what if I want to add V1 of t to cosine omega t minus 45? What's this phasor? 20 phasor minus 45. Okay, 20 angle minus 45. This one is 10 sine. This is what phasor? 10 angle 60 minus 90, which is minus 30. So this is the first phasor is 20 angle minus 45. The second phasor is 10 angle minus 30. If I add them, I have to use the complex numbers, and now the complex numbers come into the picture. How to add them? Open your calculator, click on shift, one on, and then put mode. Bunassar, you have your calculator? Who doesn't have a calculator? And then you put number 2, complex. Get it? Then you do the math. You put 20. And then you put shift. And then you put, there is a minus sign in bracket. The yellow thing has the phasor symbol. Do you see it?
Yes.
Put phasor. What's your angles? Degrees or radians? All of you, degrees?
Radians.
Check its degrees. All of you degrees? Jihad, you have a calculator? Let's do this exercise. Bunassar, your calculator degrees? Yes. Okay, put 20 angle minus 45. And then you add to it 10 shift angle minus 30. What's the answer you're getting?
24.
No, you get 22.8 minus 19.4 J. صح? You get 22.8 minus J times 19.14. Well, how to convert this into the phasor format? Again, shift number 2. Shift number 2. You have option 1, option 2, option 3, option 4, right? Put option 3, which is R angle theta. Then you will get 29.77 angle minus 40. Get it?
Yes.
Repeat this exercise now. Yourself.
فيطلع معي مو نفس الجواب.
Yeah, because you didn't follow the instructions. See? You have to put it this way. These two arrows. Okay?
Oh.
But another option, you can shift number 2, put number 3. Then that's how you get the answer. There is S and D. You see S arrow D? This S arrow D, it converts ugly numbers to beautiful numbers. Okay?
دكتور المعادلة اللي تقولها هذيك لو ما معي آلة حاسب استعملها؟
Yeah, you can use it. Yeah, you can use it. Who doesn't understand the calculator?
What's the last step?
Shift 2.
Shift 2?
Yeah. And then you pick option 3. Do you know how to use this calculator? Repeat this exercise again. امسح كل حاجة و do it one more time. Please. YouTube, do it one more time. Make sure your calculators are in degrees, okay? Forget about radians for now. I want all of you to know how to do it. Nasrallah, do you have a calculator? Why? See, you're not learning. Do it in my calculator. Quickly, quickly, quickly. You should be done by now. 20 shift theta. No. First you need to put menu. Okay? And then you click number 2. عدد مركب. Shift. Okay. 20 angle. No, what is that? Shift inch. Minus 45. Plus 10. Shift. Minus 30. And then you click this, okay? Now you have it in 22 minus 19. Then you hit shift 2. No, not shift 2. Some calculators are different, ya shabab.
Shift 4.
The calculator Arabiya is what? Okay. See, shift 3. Yeah. Shift 2. R1. Shift open option. اشتغل. Shift option. Option. Okay. Some calculators you have to click option. If you don't know, come to my office. Okay? Do it again. Do it again. Adnan, you know how to do it? Turkey, you know how to do it? Awaz, you know how to do it? Abdurrahman, you know how to do it? Nasrallah, you know how to do it? Okay, then you click shift 2 and then number 3. And then yes. That's it. Okay? Everybody knows how to do it? You know how to do it? Ibrahim? Sadiq or Salman? Sadiq. Abdul Majid, you know how to do it? You know how to do it? Salman? Ahmed Sej. Al-Awad, you know how to do it. Musaud, you know how to do it. Nasrallah. Jihad. Asir, you know how to do it. Okay. Then what you need to do is substitute Vm here minus theta here. Keep the cosine omega t. Get it? Very important. This adds 2 phasors. Another exercise. Let's do it. Our first step in combining terms. Okay. You have now how many cosines? 1, 2, and 3. Okay? The first one is 10 angle 0 plus 5 angle.
Minus 30.
Well, that's minus 30. It was a sign before. Then plus 5 angle 90. Do it.
المثال اللي قبله كان ساين وكوساين يعني فيزر مع مو فيزر.
No, we converted this sign to a cosine. How to convert it? Minus 90, which that's why it's minus 30. This one is another example. I think this signal, this was a sine of 60, you convert it. But now we have 3 signals. Now we have to do 3 signals. Let's do it. 10 angle 0. Don't forget, always run in complex mode. 10 angle 0 plus 5 angle minus 30 plus 5 angle 90. You'll get a number, okay? Shift complex number 3. The answer is 14.54 angle 8.98 degrees. Okay, 9.9. Or you can write it as 14.54 e to the power j times 9.9 degrees. That's another way of writing it. Okay? 70% of electrical engineers don't know how to do this. Okay? Did you solve it? Nasrallah. Now sit here.
But it was 80
Hmm?
after
You have to do it. Then you complain that major 2 I got 5, 4, 3 out of 20. Is it clear? Is it clear? Do it from the board. Okay? Rotating vectors, read it if you're interested. But what did I tell you? What if I have the phasor to be theta and then multiplied by e to the power j omega of t? This is what's happening here. It's a function of time. What is happening is this vector will rotate every time. Because it rotates every time, the sinusoidal signal becomes like that. The vector rotates over time. The real part fluctuates over time. And that's a proof that we can represent a sinusoidal signal over time with a rotating. Keyword is what? Rotating vector. So consider this sinusoidal signal. In developing the phasor concept, we wrote Vm e to the power j omega t plus theta. If you do the math here, you will end up with this thing. It's the real part only. The real part of the phasor, rotating phasor. Then this is phasor Vm of omega t plus theta. This can be visualized as a vector of length m that rotates counterclockwise in the complex plane. Where is your calculator, Mish'al? Do this using calculator. Okay? At home, not now. Or after class, come to me, okay? In the complex plane with an angular velocity of omega radians per second, the voltage Vt is the real part, which is illustrated in this figure. As the vector rotates, it's a projection in the real axis out of the voltage as a function of time. The phasor is simply a snapshot of this rotating vector at time t equals 0. What do you want to learn is two concepts. This is a snapshot with that does not take time into consideration. If you want to take the time, you need to multiply it by e to the power j omega t. If you multiply it by e to the power j omega t, it becomes a rotating vector over time. Okay? Some relationships of phasors, you can add them. So for example, V1 of t is 3 angle 40. V2 is 4 angle minus 20. This is 3 angle 40, 4 angle 20. This is the real axis, this is the imaginary axis. Because the complex vectors rotate counterclockwise, we say that V1 leads V2. Or V2 lags. يعني V1 تسبق ال V2 و V2 متأخرة عن ال V1. Lags يعني متأخرة. Lag. How does this look like in real time? In real time, the peak of V1 appears before the peak of V2. The peak of V1 appears before. That difference is the phase shift. The phase shift is what? 40 minus 20. 40 minus 20 is 60 hertz. Let me repeat the concept of leading and lagging. We have two signals. One is 3 cosine. Angle 40, how to make it like a phasor is 340. We have another one, is 4 angle minus 20. If you plot them, V1 leads before, counterclockwise before V2. If you put them in real time, you will notice that the blue one, V1, its peak is ahead of V2 by 60 degrees. I know, this is in omega t, not in t. How did you do that? It's just 40 minus 20. So you can know the phase shift between two signals by subtracting the angles of the phasors. Okay. Complex impedances. Any question about phasors? Over time we will train ourselves. I promise you. Okay?
لا بقول لما تطلع البتن ما يجيب
Not really. Lag means the two sinusoidal signals, one its peak appears before the other. That's the right technical word. Its peak appears before the other. يعني سابقتها في أقرب الوقت هنا صح؟ Earlier time is left, so this appears here. In phasors, it is more يعني ahead of the angle. Now somebody can say, oh, 4 is ahead of that by the long. No, لازم تصير زاوية حادة عشان تقيسه. Okay, Ibrahim? Get it? So V1 leads V2. This implies V2 lags V1. Complex impedances. Okay, we already talked about phasors. So up until here was math. Okay?
هذا الموضوع يستخدمونه في الشبكات.
Yeah, it's used almost everywhere. Everywhere you have signals. Digital signal processing, AI, artificial intelligence, machine learning. You have to know phasors. Communication, power, everything. Okay, consider an inductance in which the current is sinusoidal given by, now we are applying the math into electric circuits. We have I sub L of t to be what? Im sine omega t plus theta. Write it in phasors. IL phasor is going to be what? Im angle?
Minus t.
No, just theta.
It's sine.
Sine.
Oh, you're right. My bad. Theta minus 90. Because this is Im cosine omega t plus theta minus 90. Get it, ya Mishal? You have to convert sine to cosine, and then you have to subtract by 90 here. That's why we subtract by 90. Because everything has to be cosine. The voltage is written by this formula, which is VL equal LdIL dt. So what is VL? L di of L dt. It's going to be what? Im L. What's the derivative of let's do the derivative of
Cosine.
well, we can do the derivative of sine, and then we can write it as phasor, because it's already cosine. Omega of t plus theta. This is the derivative, okay?
We have omega.
No, because we wanted, oh yeah, then we have chain rule times omega. So this would be what? Omega m I m l cosine of omega t plus theta, right? As a phasor. So what is VL phasor? Always write the word phasor so you don't forget. Phasor. Omega m l I m l angle theta. Omega L Im angle theta. The IL is Im theta minus 90. What does this imply? This implies the voltage leads the current in an inductive circuit. V is leading I. Leading. The peak of V, the black curve, is before the peak of I, the blue curve. The phase shift is what? 90 degrees. Why? Because if you subtract theta minus 90, minus theta is going to be minus 90 degrees. The phase shift is 90 degrees between voltage and current. Notice that the current lags the voltage. Now the current lags the voltage. Lags. Tamam? How to know? You go in quadrant 1. See, who is in quadrant 1 first? It's V1. If they are nothing in quadrant 1, you go to quadrant 2. Who is here first? The key here is you have to pick the small angle, not the big angle. Okay? زاوية الحادة. So V1 leads IL. IL lags V1.
So,
Yes.
Sheikh, تقصد بالبيور inductance؟
No resistor, nor capacitor, nothing. It's just pure inductance, no R. Okay? Jihad. Get it? Now, again, what is the definition of what is impedance? What did I tell you impedance بالعربي? معاوقة. How to calculate المعاوقة? Well, you can use, you remember we had V equal IR and we said R equal V over I? Impedance is the same, you have to put Z equals V of L over I of L, and this is the Z of L. If you divide the phasors, it will be much easier. Why? Because dividing cosines is hard. So let's divide the phasor. What is this phasor? Omega M, I M, L, angle theta. Omega M, I M, L, angle theta. Divided by, what is I? I M, angle of theta minus 90. The final answer will be what? Omega M times L, angle of, in dividing phasors, you put theta minus 90. You subtract the angles, that's why it's easier. Then it will be angle of 90. Angle of 90 is nothing but the number J. So it will be J omega M times L. Now you don't have to derive it every time. Now, from now on, the impedance of an inductor that has L, that has a current IL, or which is IM angle theta minus 90, and a voltage drop of omega M IM L of theta, the impedance of L is nothing but J times omega M times L, where omega M is 2 pi F sub M. We'll explain it with an example. Yeah, the J is, okay, put it in your calculator, put square root of minus 1 and write it as a phasor. Exercise. What is my calculator? Yeah, do it. Just put the letter J or I and find its phasor representation.
One phasor 90.
One phasor 90. Isn't that phasor 90 is just a J? صح? Get it? I know this concept is hard. That's why we want to have an additional one lecture. Because I want to spend my time teaching you how to do it properly. The phasor voltage is equal to the impedance times the phasor current. Impedance that are pure imaginary are also called reactance. Now, the word reactance is for inductors only. It's purely imaginary, also called reactance, also for the capacitor. But stick with the word impedance, okay? We're not going to use the word reactance, okay? المعاوقة للinductor will mean الcapacitor. Reactance, I don't know what's called بالعربي. I'm interested. What's reactance بالعربي? No, there has a name. They come up. It's usually Syrian engineers who come up with those names. مفاعلة الكهربائية المفاعلة. It's both in inductors and now if it's purely J times whatever هذه تسمى مفاعلة. But just call it معاوضة. Impedance, okay? For the capacitor, the opposite, a little bit it changes. I'm not going to write it on the board, but it's VC equals ZC times IC. The impedance is minus J times 1 over omega C. If you do the math, it's 1 over omega C angle minus 90. How to do that? With the same way. You find the equation V, and then you find I. I is what? C dV dt. You find the both phasors, and you divide V over I. Then you will have the expression of 1 over J omega C. Don't use this one. Use 1 over J omega C. So what's the impedance of a capacitor? It is just, now if you want to do this exercise at home, we're not going to ask you to do it in the test. But you remember, you have to start with V of C equals C times di, no. V of C equals C times di of C dt. If you do this as phasors, then you will have Z of C equals 1 over J omega C, which is in phasor 1 over omega C angle minus 90. Put 1 over J in the calculator, it will be minus 90. Okay? Notice that the impedance of a capacitor is also pure imaginary number, which is called reactance. However, with the capacitor, the current leads the voltage by 90 degrees. The current, the blue curve, its peak is before the black curve by 90 degrees, or the voltage lags the current. Memorize these words. Okay? For resistors, we already explained it. There is no phase shift, it's purely resistive. There is no J. V phasor equal R times I phasor. R is not an imaginary number in this case, because resistance is a real number, the current and voltages are both in phase. Okay? Memorize this table. Memorize this table. Memorize this table. Okay? I will do this example later. We don't have time. But any question for the lecture? Okay? So, in summary, just to remind you, our plan, we will have a quiz this Thursday from chapter 3 from the slides. We change numbers. Maybe we will have some conceptual questions. Words, يعني أكمل فراغ صح وخطأ. It's only from the slides. Then we will have Sunday vacation. Tuesday we'll have a morning lecture, an evening lecture. Zoom, no attendance will be taken. Okay? Why? Because we are late. And if things go well, maybe we will cancel the last lecture, which is the one of the Sundays before the final. Okay? So we will do it virtual. So we will have 2 lectures on Wednesday. No, Tuesday. Thursday. Okay, you have any question?